Hello, very good morning to all of you students. How are you? I hope you all are happy, healthy and fine at home. Do you remember what were we discussing yesterday? I think yesterday we were discussing about the chapter number 4 which we have completed, and the last point I think we have seen, which is the P-Sc reaction, how P-Sc reaction takes place, how many steps are involved in a mechanism, what are the starting material and the reagent used there, and what type of the product it form, why it is called as a P-Sc reaction, and the important question of that chapter we also discussed in a previous lecture. So today we are going to start as a fresh and the new chapter, which is a chapter number second last chapter of this semester. We are talking about the semester number 3. So this is a chapter number 5 and we will see that last one. But here today we are going to discuss about the elimination reaction, right? This is a chapter number 1, organic chemistry, and now T.Y.B.Sc organic chemistry, chapter number 5, elimination reaction. So first of all, how do you define the elimination reaction? The word itself indicate there is something is removed from the starting material or the substrate, or what we can call it as a reactant. So let us see the definition of this elimination reaction. A reaction in which two atoms or group of atoms are removed from the reactant to form a product with higher degree of unsaturation is known as elimination reaction. Understood this? I am repeating this again. A reaction in which two atoms or group of atoms are removed from the reactant or the substrate to form a product with higher degree of unsaturation is known as elimination reaction. And generally the atom or group of atoms are eliminated from the relative position 1, 2, and that's why it is referred as 1-2 elimination reaction generally. And therefore let us see how the general reaction, how they are taking place at 1-2 elimination reaction. What does it mean? Let us see here generally. Let us see here is a X, and now here we are taking general reaction. Here you can take as a Y, right? X and Y. This 1 and 2, this is a substrate, or what we can call it as it is a this is a substrate, or it is a reactant. And as we know, this is a 1 and this is a second. And now look at here, where two groups are present, one at 2 position, second at 1 position, and this 1 position we can also call as alpha, and second position we can term as a beta position, right? And when the 1-2 elimination reaction takes place, 1-2 elimination reaction takes place, means this and or it is called as a beta elimination, we will see later on. But what is happening there, this X forming as a bond over there after breaking this, and this is a departure, so that you are going to get here C double bond CH, this bond remains as it is, and plus here is a X and Y, this group is means two atoms are removed from the substrate according to our definition. What is a reaction in which the two atom or group of atom are removed from the substrate to form the product with higher degree of unsaturation is known as a this we are getting as a alkene formation, right? This is alkene formation, and that is a living group. And now let us see another one, another example here. X, there is a double bond C, then here we can write as a Y, right? Again there will be a 1,2 elimination reaction over there. Again this carbon atom we can term as a 1, this carbon atom we can term as a second one, or this one we can call it as alpha, this one should be the beta. Alpha, beta, 1,2 elimination takes place. What you are going to get here? C triple bond C, this one, and plus X and Y. This is the side. Now here again X bond is the bond between carbon and X is broken, and there is a formation of triple bond, and at the same time there is a departure of the leaving group. Leaving group goes away, and therefore you are going to here also as a 2 atom or group of atom is removed here, and we are getting this one is a alkyne, right? These are the higher degree of unsaturation we are getting. In case of the majority of 1,2 elimination reaction, the atom that is from C2, the atom that is from C2 or C beta is hydrogen. Normally from this is a C2 means X is equal to hydrogen atom. Generally in a 1,2 elimination reaction, X is equal to H is removed and some good living group from C1, and this Y is nothing but as a good living group. Good living group. GLG means good living group is removed from this, and such 1,2 elimination reaction is termed as beta elimination reaction. Understood what is beta elimination reaction or what is 1,2 elimination reaction? Why it is referred as a beta elimination reaction? Because from this, whenever the elimination reaction takes place, from beta side there is a loss of hydrogen atom. Hydrogen is lost from the beta carbon atom, and therefore it is referred as a beta elimination, or it is known as a 1,2 elimination reaction. 1,2 elimination reaction means what? Again the two atom they are removed from the relative position from 1 and 2, and that's why it is known as a 1,2 elimination reaction, or it is referred as a beta elimination reaction. Let us see again. There is a hydrogen atom, then here I am again taking as a general reaction. This is a Y is a good living group. Here I am purple, this one is a alpha, this one should be the beta. Now this is known as a beta elimination reaction, right? Beta elimination reaction means what? Generally from beta position the hydrogen atom is lost, and we are going to get the product here, this one, a double bond C, then H, Y. This type of the group get eliminated, and this type of the reaction is known as a beta elimination. Understood this? All beta elimination reaction are 1,2 elimination reaction. The converse is not the true always. Beta elimination reaction also lead to the formation of carbon double bond, carbon nitrogen double bond, or carbon oxygen double bond. Other elimination reactions such as 1,1, 1,3, 1,4, 1,5, 1,6, such type of the reaction, such type of the elimination also possible, but we will be restricting our discussion to 1,2 elimination reaction, as they are more common and synthetically very important, and that's why we are discussing over here. And some of the most commonly known 1,2 elimination reaction are given here. We are going to see over here, and notice that these reactions are nothing but the method of preparation of alkene and the alkyne starting from different functional group. Remember that one. And let us see some of the reaction which are taking place in a different medium. That what are those different medium? Let us see over here. So let's begin with the basic medium. First one in a basic medium. Basic medium, and these reactions are carry out in a basic medium to form the different alkene or the alkynes depending upon the nature of the substrate. Let us see first one. First general reaction we are going to learn here R, then CH, I am writing here CH2, then CH2, here Br, right? So this one is called as a 1,2 position, or this is referred as alpha. Why alpha? Whenever there is a halide attached, that carbon atom is always termed as alpha, and adjacent carbon atom is termed as a beta, gamma, and so on. Remember, whenever there is a halide groups are attached here, specifically the bromine atom is attached over here, and that's why it is referred as a alpha halogen, alpha beta, right? And now this will be treated with base, and if you employ as a base over here, if you use as a base, what will happen? There is a removal of one hydrogen from here and one Br from here, right? And after removing this type of the reaction is known as dehydrohalogenation. Remember, this word itself suggests that D means what? Remove, and hydro means what? Hydrogen. Dehydrohalogenation. This is one of the process, means in an elimination reaction, one of the hydrogen atom always from beta carbon atom, and the good living group is lost, and we are getting the formation of the alkene. And this type of the reaction, what is dehydrohalogenation reaction? Explain with suitable example. That type of the question may appear in the exam, and remember, at that time you should remember D means removal, and hydro means hydrogen, and halogen means halogen, and the combined process is known as a dehydrohalogenation. And what you are going to get? You are going to get here the product RCH double bond CH2. This is the alkene we are going to get. General reaction we are talking here. Here we are getting as a alkene over there, general, right? And now second one, suppose second reaction over here. Second, if you have a R, then CH, I am writing this H, then here CH2, and OTS. OTS, we know that it is a good living group. While studying as a SN1 reaction, how will you convert the bad living group into as a good living group? Means OH is a bad living group. By converting that into as a good living group, there we are using as a reagent, that is a tosyl group, tosyl chloride. It nothing but as a paratoluene chloride, and which is a excellent living group. Why it is an excellent living group? Because it is stabilized by the sulfonyl group, S double bond O, and that's why it is there. And if you use here again as a base, what you are going to get again is a product. Elimination reaction takes place, and you are going to get here is again is a alkene over there, right? And now let us look at as a third reaction. How the third reaction again is the same. R, then CH, it is a hydrogen atom, then here is a CH2 here, and then 3 times CH3, thrice OH minus, and here the positive charge comes on that nitrogen atom because it attached. There are the 4 bonds are there, 3 with that methyl group and 1 with this methylene group, and therefore this reaction just heat it. This reaction just require heating, and it is one of the famous reaction. The name of this reaction is Hofmann elimination. Hofmann elimination reaction. Hofmann is the scientist name. He discovered this reaction first time, and that's why name is given to this reaction is a Hofmann elimination. Here also this is also known as alpha, this one is a beta, or we can call it as a 1 2, here also as a 1 2 or alpha, and this should be a beta, and the product you are going to get RCH double bond and the CH2, right? So all these are taking place in a basic medium. So these are the reaction. Now let us look at as a fourth reaction which is again is a R, then CH, here Br, then CH2 Br, and then it is heated with, it is a excess base. Here is used as a excess. How much is the excess? Excess means in the large amount you can use it. This is also known as a dehydrohalogenation. This process also termed as dehydrohalogenation. Dehydrohalogenation means what? D means removal and hydrogen and the halogen atom from this, and we are going to get here a dehydrohalogen, one hydrogen from here and Br from here, one hydrogen from here and Br from here. That type of the two molecule, because we are using as a excess amount of the base over here, excess base, and therefore you are going to get here the product RC triple bond C and H, and this type of these are the alkene, right? These are the alkene formation, and a olefin we can call it, and this is the alkyne formation. Is a alkyne formation, right? So in this way we have seen there are four kind of the reaction taking place in a basic medium. Now let us move on to the next medium, that is a acidic medium. Here we are going to see the acidic medium, the reaction, what kind of the reaction takes place in a acidic medium, that we are going to see over here. Let us see the acidic medium. Here you can write as a acidic medium. In a acidic medium, four reaction we have seen. Now is the reaction number 5. In a acidic medium, let us see the same thing, R, CH, H, then here is a CH2 OH, that is alcohol we are using, and this will be treated with concentrated H2SO4. Remember, this is the king of chemical, and it is used over there for dehydration. This is known as the dehydration. Remember, D means removal, and hydration means what? Water. So removal of water, 1H from this we can refer as a 1, this is a 2, or we can say alpha, and this is a beta. So there is a one hydrogen atom from here and OH from here, and as we know that concentrated H2SO4 is a very good dehydrating agent. It removes the water, and we are going to get here RCH double bond and CH2. We are going to get here is a alkene formation, right? Remember this one. This is a compound we are going. Only one reaction is in a acidic condition. Now let us look at as a neutral condition. Neutral medium, right? Neutral medium. In a neutral medium, let us see some of the reaction also carry out in the neutral medium. So here let us see reaction number 6. Suppose we have a RCH, then Br, then CH2 again as a Br, and this is known as dehalogenation. This is known as a I minus, or we can use as a zinc dust. This is known as a dehalogenation. Remember, look at the word here. D, as we know that D means remove, right? Removal, and halogenation means halogen atom. This Br and one Br from here, both Br to get eliminated, we are going to get here RCH double bond CH2. This is the alkene we are going to get here, right? So this reaction is taking place in a neutral medium, and that's why it is shown here. And the last one, reaction number 7 over here, that is again R, then CH hydrogen atom here, then CH2O, C double bond O, CH3, just heat it, just required as a heating. So that type of the reaction is called as a pyrolytic elimination. This is known as a pyrolytic elimination reaction, this one, elimination reaction. And what is going to happen here also as this beta hydrogen atom is going to lost over there, and this acetic acid, and finally you are going to get RCH double bond CH2, that is a alkene over there. So in this way we have seen the general reaction taking place in a different medium like basic medium, acidic medium, and the neutral medium. All these three medium we have seen how they are reactions are taking place. Now let us look at as a mechanism of 1,2 elimination reaction. General mechanism we are going to learn here, how the general mechanism of 1,2 elimination reaction takes place, that we are going to see over here. The mechanism of 1,2 elimination reaction. Mechanism of 1,2 elimination reaction. Mechanism of 1,2 elimination reaction, and the 1,2 elimination reaction which take place in basic medium are characterized by the following. Let us see here again is a general, because we are talking about the general mechanism, and for general mechanism we are taking here Y is a good living group, and then we are treating with the base. B stand for base, and as we know that the function of base which will abstract the proton, and we are going to get, this is, you can call it as a reactant, this one reactant, or we can call it as a substrate, right? Substrate, reactant or the substrate. And what is going to happen here? Here first one is a loss of or a living group get departed, and this base can abstract the proton from here, and generally you are going to get here the double bond C. This is the alkene we are going to get, no doubt about it, and plus BH, that conjugate acid we are going to get over here, and here Y is a living group, right? This is called as a conjugate acid, and this is this is known as a living group. So in this way we have got this one. Now the question arises here, how this mechanism is taking place. This base, as we know that base is a compound, or base is a species which can abstract the proton from here. When it is abstracting as a proton, it get protonated, and this is called as a conjugate acid, and there is a formation of the bond between C and D. Now let us look at here the first point, what is happening here, breaking of C alpha Y bond, breaking of BRA, breaking of C alpha Y bond, first one, right? What is happening in the first case, breaking, this is a alpha, this one is a beta, or we can call it as this is a one, this is a second. So what is happening, breaking of C alpha Y bond takes place first. This is a breaking takes place over there, and after the breaking, what is happening, the substrate has a good living group Y, This substrate has a good leaving group Y, and during the reaction CY bond breaks heterolytically, so that the bonding pair of electron is taken away with the leaving group. So this is the thing happening here. Breaking of the C alpha Y bond. This is a in the substrate there is a good leaving group is a Y. When during this reaction the leaving group taking the bonding pair of electron along with itself and are taking away from this, and therefore this bond is breaking heterolytically. So that is the situation happening there. Now in the second case, what is happening? The breaking of C beta hydrogen bond, right? The second step happening in this case, the breaking of C beta hydrogen bond. The base used, whatever base used here, it will abstract the proton, and the bond breaking between that hydrogen and carbon also heterolytically, because the bonding pair remains along with the beta carbon atom, and so this type of the things are happening in the second step, right? And now the third one, what is happening there? Formation of pi bond between C alpha and C beta bond, right? So this is a third thing happening over there, formation of the pi bond between C alpha and the C beta bond. Now whatever these bonding pair of that present on the beta carbon atom utilize to form the pi bond over there. So this type of the general things are happening over there. Generally the bases used are strongly basic in nature, such as hydroxide OH, such as OH minus. This is called as a hydroxide, and or OMe, that is a methoxide alkoxide, methoxide. Then OET, that is a alkoxide, not alkoxide, ethoxide. This one is called as a ethoxide. Suppose as a O tertiary butoxide. This is called as a tertiary butoxide. These are this type of the strongly bases are used in an elimination reaction, right? So 1,2 elimination reaction involve breaking of the 2 sigma bond, between carbon and hydrogen. Another one is a carbon and the leaving group, and formation of the 1 pi bond. So this type of the general things are happening over there, and by depending upon the timing or the sequence of bond breaking and bond formation, 3 possible mechanisms could be suggested. Number 1 is called as the E2 elimination reaction. In this chapter we are going to learn. Then E1 elimination reaction and the E1CB elimination reaction. So these are the 3 mechanism we are going to learn, similar to as in a SN1 in a elimination in a nucleophilic substitution reaction we have seen SN2, SN1 and SNI. Here also we are going to learn three of them. It's a E2 mechanism, E1 mechanism and E1CB mechanism. What they are, we will see in the next lecture. Let us stop today here. Thank you. Have a nice day.